Okay, this is going to be a pretty short video. I really just want to do a quick trig review that will help us with regular polygons, and then a little bit of a special right review that typically involves hexagons. Again, so when we use trig, we're talking about the three functions sine, cosine, and tangent. We talk about the hypotenuse of a triangle and then the adjacent and the opposite side. So if this lower angle is our angle, and this variable theta is usually what we use to represent an unknown angle. The adjacent side is the one next to the angle, the opposite side is the one across from it, and then a hypotenuse, of course, is the longest side in a right triangle. It's opposite the right angle there. So sine relates the opposite to the hypotenuse. Cosine of an angle relates the adjacent to hypotenuse, and tangent relates the opposite to adjacent, right? There are three different trig functions for the three different combinations. Opposite and hypotenuse, adjacent hypotenuse, opposite and adjacent. And again, SOHCAHTOA is kind of a mnemonic phrase, or maybe a mnemonic word, that represents sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's one of the few that I think is helpful. Okay, so let's just do three different examples, and the variable can kind of be in different spots. So this time I made the given value, the number, the hypotenuse. Over here I made it the adjacent side, and then over here I made it the opposite side. So they're all a little bit different in terms of how we would solve. Again, this is just a trig review, but doing these triangles is exactly what you do when you find the area in or for a regular polygon. So if we have something like this, and let's say I'm interested in h, I want h, which is opposite, and I have the hypotenuse. Opposite and hypotenuse tells me to use sine. So I'm going to say sine of 54 is h over 10. I really want h by itself, so I'm going to multiply both sides by 10. So 10 sine of 54 equals h, and then I'm done. Then I just type that in. 10 sine of 54 on my calculator. When I say 10 sine of 54, I mean 10 times sine of 54. And I get h equals 8.09. Okay? If I have h and I have 10, I actually can use the Pythagorean theorem to find x, or I can use cosine. Cosine of 54, cosine is the adjacent over the hypotenuse. And again, x is right where I want it to be. It's only a one-step algebra. All I gotta do is multiply both sides by 10 to get x, and then 10 times cosine of 54, x equals 5 point, looks like about 88. Okay, all right, this other one, let's switch colors. This one I'm going to start with the adjacent side. Let's go ahead and find h first. So if I want to relate opposite and adjacent, I'm going to use tangent. So I'm going to say tangent of 70 is opposite over adjacent. Again, this is going to be one-step algebra. The h is right where I want it to be. It's in the numerator, so I'm going to multiply both sides by 6. And then I'm just going to type that in. 6 tangent of 70. Looks like 16.48. Okay, now this one's going to be a two-step algebra. So when I use cosine to relate the adjacent to the hypotenuse, cosine of 70 is going to be 6 over r. Now r is the variable in the denominator. I still am going to do the same first step. I'm still going to get rid of the fraction. I'm going to multiply both sides by r. But now I need to divide by cosine of 70 to get r all by itself. And then I can type that in. 6 divided by cosine of 70, r is 17.54. Okay, and this is two-step algebra. When the variable is in the denominator, it's going to take two steps. I'm going to move the denominator over, move the variable over, and then I'm going to divide by cosine. And then, okay, and now I'm going to do this one over here, which I'll do up here. I'll switch colors again. So this one, I have the opposite side. Let's go ahead and do tangent first. Why not? There's no real rhyme or reason. Tangent of 75 is opposite over adjacent. Opposite over adjacent. If this is the angle, this is opposite, and this is adjacent. I'm going to multiply both sides by x. I'm going to get rid of the fraction, and then I'm going to have, if I want x all by itself, I need to divide by tangent of 75. 10 divided by tan 75, x equals 2.68. In this one, just for fun, let's say that we know x squared plus 10 squared equals r squared for the Pythagorean theorem, and I know x. So I'm just going to do 2.8 squared plus 10 squared and get 107, and then I'm going to take a square root of that. I'm going to use the Pythagorean theorem to find r of 10.35. Okay, so kind of three different examples. Again, I can use sine, cosine, and tangent. The variable can be in the numerator, the variable can be in the denominator. The variable, I don't know if it's ever actually the angle in this case, but you know what? I'm going to do that real quick just as a thorough review. If, let's say, I had this triangle, and I knew this was 6, and I knew this was 7, and I was interested in this angle. And again, it's one of those things, what trig function are you going to use? Well, if this is the angle, I have the opposite and I have the adjacent, so I'm going to say tangent of theta is 6/7. And in this case, I want to get rid of the function tangent, so I'm going to use the inverse function, inverse tangent. So I'm going to apply inverse tangent to both sides of the equation. The tangent, inverse tangent will cancel each other or undo each other. And then I just type that in. Second tangent on your calculator and then do 6/7. So I get an angle of 40.6 degrees. So I can find an angle using inverse tangent. Okay, so one step, because they're all the variables in the numerator. 2 steps, algebra, because the variable's in the denominator. And then actually inverse trig if you ever want to find an angle. Okay, let's go back down here. I tried to fit this on one page. This is a special right triangle. Remember, a 30, 60, 90 triangle is going to pop up a lot with hexagons. And again, it's the relationship that we know that if it's a 1 square root of 3, 2 relationship, meaning the long leg is the square root of 3 times the short leg, and the hypotenuse is always double the short leg. So if we did an example right here, if I knew the hypotenuse was 12, I would immediately know that the short leg was 6 and the long leg was 6 radical 3. Again, this is important in this unit of regular polygons because it's going to pop up in hexagons. Remember, if you think about a hexagon is going to have an interior angle of 120. And so when you break that interior angle down into half right there, that angle is going to be 60 degrees. If that angle is 60 degrees, you're going to form a 1 radical 2. So whatever this is, if this is x, this is just double x, and this is the square root of 3 times x. And when you do that, then you're able to find the area and the perimeter in exact. Remember, if they use the word exact, they mean go ahead and leave the square roots intact. Don't change them into decimals. Okay? Hopefully this was a good review of sine, cosine, and tangent, the algebra and the trig required to solve for missing variables, and then a reminder of our special right triangle. 30, 60, 90 is 1, 2 radical 3. That's like a classic example, and then where it comes into this unit is doing hexagons. All of this stuff comes into trying to find missing pieces. This is like you had the radius and you wanted the apothem. This is like you had half the side length and you wanted the radius and the apothem. This is if you knew the apothem of the polygon and you wanted another radius and eventually the side length. Okay, so hopefully this was a good review of trig.